We're still factoring. What is factoring again? It's like undoing. It's like taking things out. We're going to look at some bigger things now. We're going to start factoring out so we get binomials times binomials. The first way we do it is called the grouping method. This is for the easiest types of equations we'll see. It does get harder. The first thing you need to do for the grouping method, you need the listings in descending order. What is descending order again? Matthew? Yeah, the highest exponents to the lowest. So we start with 2, and then there's only 1, and then there's 0 over there, right? There's no x's left. See, I think. Okay. Yeah. It's not that hard. The important thing about the grouping method is you need 4 terms for it. All you're going to do is you're going to cut it in half. So draw a line like that. Cut it in half. So you're left with 2 terms and 2 terms. If there's a negative sign on this term, it goes with it to the right. Go. Yeah, it'll only work if we have 4 terms. Yeah. Then you're going to take the greatest common factor of everything on the left side, and you're going to take the greatest common factor of everything on the right side. So that's what we did yesterday, if you guys forgot. What's the greatest common factor of x squared? This one right here. Plus 2x. Look at the coefficients. Can you take a 2 out of both? No. So you can only take a 1 out, right? But how many x's can you take out? 1. So your greatest common factor for this side was x. What was your greatest common factor for this side? You can't take an x out. -4. So you'll write it out like this. Like that. We took our x out of the first 2 terms, and we took our -4 out of the next 2 terms. And you should notice that the binomials are the same. The x plus 2 is the same as the x plus 2 here. Meaning we can factor out an x plus 2 away from our x and away from our -4. That gives you a final result of right there. You factored out an x plus 2, and you were left with x and -4. That's where the x minus 4 came from. That's all we're going to do. Examples. It's the best way to learn. What's the greatest common factor in this first one? X plus 7, right? We have an x plus 7. We have an x plus 7. So you can factor that out of both of them. So what are you left with? If you take x plus 7 away from this first one, what are you left with? 3x. What are you left with for this next one? Plus 2.
Why are they on the old?
Because you have to, because we took out a binomial, right? We factored that out. So if we were to now put it back in, we should get the same answer. So we took this out by dividing it, right? We divided x plus 7 away from 3x times x plus 7. So now it's just the 3x left. It's just the 2x. John, and then
why do you like write 1 x plus 7? Like there's 2 there and you factor them out, but why do you only write 1?
Why did I only take out 1 x plus 7?
Yeah.
Because there's 2 here, but there's 3x here. We don't know how many there are. There's 3x worth. We don't know how many. If this was 4 times x plus 7, then we could take 2 away from both, right? That would make sense. Matthew.
Can you put like a squared symbol on the outside of the brackets of x plus 7?
A squared symbol?
Yes.
A squared symbol would mean it's all this times x plus 7 again. We don't want to multiply x plus 7 again. We just want to multiply it in once. What's our greatest common factor of this one? 4a plus 1. So we left with 9a plus 1. Yes, 1. When you took 4a plus 1 in the second term and divided it by 4a plus 1, you were left with what?
1
Right, because if you were to multiply that back in, you would get this, right? Yeah, that's why there's brackets. This last one, what do we? Yeah, sure. Is there a 5a plus 1 in the second term? Yeah, is there a 5y plus 1 in the second term? There's a 3y plus 2 that you can take out of both terms. Yeah, yeah.
3y plus 2.
Yeah, 3y plus 2.
And 9y plus 1.
And yeah, you're going to go brackets again. So 5y plus 1. And then plus 4y. Because that's what we were left with for the first one, and that's what we're left with for the second one. And you can actually simplify that inside, right? You can combine it to be not and one. Yeah. Any questions? No. So this is what we learned yesterday. This is just factoring out a greatest common factor. And seeing what our remainders are. Yes, Matthew? Yeah, just so you know that that's on the left, that's on the right. Okay, now we're going to move on to what we're learning today. What do we have to do? First thing it says, put it in what order? Ascending. Already in ascending order. Right? X squared, x, no x left. Now what do we do, Matthew? You don't have to go, I see what you're saying, because 6 is greater than 3. That doesn't matter. Just the exponent on the x's matter. You could do that and you would get the same answer. So if you flip them, if you put 6x here and 3x there, still get the same answer later on. What's the next thing we do, Jared? Or do you have a question? Pardon? Jared?
Draw a line.
Draw a line. You're going to take the greatest common factor out of this. So what's the greatest common factor of those first two terms? Matthew? X. So what are you left with, Matthew? X plus 3. We took one x away, so there's only one left. And we took that x away, so there's only 3 left. Now, we're going to factor the next side.
2x.
We took away an x from multiplication, right? So we divided out an x. We didn't subtract an x. We divided an x out. Yeah, I see what you're saying. Because you're right. The word I used was took away, which is referred to as subtraction. We divided an x out. Because if we multiplied it back in, how would it look? X squared plus 3x. So you should be able to multiply things back in to check your answer. What's the greatest common factor on the next one, Aaron?
6.
6. So plus 6. What's left?
X plus 3.
You got it. You know you did it right, and that are the same.
Or if you got 3 out of it.
Or if what's right?
Or if you just agree to it.
Did you just agree to it? What do you mean?
Like, put the 6 in there.
Oh, yeah, if you multiply back in, yeah, the same. I thought you meant like, yeah, it's just right because I said so. Yeah, I don't think it works like that. Matthew.
Well, like in the next one, what is it?
We're not done this one yet. All you've done is the first 2 steps. Or the first 3 steps. Now we have a greatest common factor we have to take out. What's the greatest common factor of this and this? X plus 3. That's why it only works if you got the same thing. So you take out your x plus 3, and what are you left with? X plus 6. Where did I lose you, Dawson? Where did I lose you? Everywhere? Okay. Let's try another example. If you didn't put your hands up or just holler when I lose you the first time. First step. No. We're going to go step by step. First step. Descending order. It's already in descending order. Second step. Draw a line. If there's a negative sign, the negative sign goes to the right. So the negative sign is on the right of the line. You're now going to take everything left of the line, and you're going to take out the greatest common factor. So that's the little thing we learned yesterday. The greatest common factor. So what's the largest number that divides into 8 and 4? Matthew? 4. Yep. You're right. The A also comes out. How many A's? We have 1 here and 2 here, right? So you take out the lower amount. When you take 8A squared and you divided it by 4A, what are you left with? 2 what? 2A. You divided an A out. When you took negative 4A, you divided by 4A, what are you left with, Chloe? Here's that, Chloe. Negative 4A divided by 4A is negative 1. This next one's going to be a little trickier. Because we know our end result is we want something A minus something, right? We want 2A minus 1. But this is a positive and this is a negative. So whatever we factor out, we want to factor out a negative so it'll flip those signs around. Because we want our end result to look like 2A minus 1. So what would we factor out of this next one? Yeah, Murphy, a negative 5. If you took out just a 5, your result would be 2A plus 1, which doesn't work. We want 2A minus 1. That's why we took out a negative 5 instead of a positive 5. Yeah, so yesterday when we were doing just greatest common factor, you only take out negative if both things are negative, right? That's for when you're finding greatest common factor. So if I gave you an equation and said just find the greatest common factor, go with that rule. Because this is factoring 4 things and using the grouping method, we have to do it this way. So Aaron, what are you left with when you take out negative 5? Yep.
When you do negative divided by negative 1, you get negative 2A and the 1 and then you mark out that one too.
So, yeah, you could have taken out a negative 4A and a positive 5 over here. Okay? And then you would have had negative 2A plus 1 as your common factor. That also works. It doesn't matter. You'll get the same answer both. Like you'll get a different answer, but the same answer. So if you were to multiply back in, it would get you the same answer. When we took out negative 5, what are we left with, Murph? Right here.
You're left with 2A.
Yeah. We know we did it right because that and that are the same. Now what's your greatest common factor, Jared? Yes, sir. And then you multiply it by 4A minus 5. You don't add it. Because we divided it out as a factor, you have to multiply it. You don't add it. Matthew. No, not everyone's written it yet.
Test or quiz.
Quiz. We got 2 more examples. If you have a question, you got to ask. What's the very first step? Time. Pardon? That's the second step.
Oh, descending.
Descending order. It's already in descending order. Second step, time. Draw the line.
Will it always be in descending order or not?
No, it won't always be in descending order, but that's why I'm asking, yeah. Josh, you find the greatest common factor of the things on each side of the line. What's your greatest common factor here, boys? You got a 3, and how many A's? 1. And what are you left with on the inside? Hannah? So 6 divided by 3 is 2. 8 squared divided by 8 is, you got it, minus, Johnny, what are we, oh, Taylor, what are we left with? Just 3. You got it.
Why didn't you ask me?
I was going to ask if your hand was up, so you're going to do the next one. Taylor put her hand up. I don't know what that is. It's from another room. Negative 2a plus 1. Bit of a trick. What are we going to factor out? Emma, what do you think? Just negative 1. We can't take any a's out. And we don't have any numbers that divide into both 2 and 3. All we have is 1. But we want to take out a negative 1 because we looked right here. And we saw we wanted to result in a negative. Right now we have negative 2a plus 1. We want to flip it so it's 2a minus 3. So Emma's right. Factor out a negative 1. That'll be 2a plus 3. That's where these things get confusing. Is trying to flip the negative around. It's minus, yeah, sorry. Thank you. What's your greatest common factor? 2a minus 3. Take 2a minus 3 away. And you're left with 3a minus 1. Matthew.
Just a coincidence that they would end up doing the same.
It will come out that way. It's not a coincidence. If it's not coming out that way, then you factored something wrong out. So if you don't get 2a minus 3 and 2a minus 3, you got to check what you factored out on each side. One of them's wrong. You probably could take something bigger out. It's usually the issue. Joe, what's your question? Good? Okay, perfect. All right, last example. You guys have a couple more examples on your booklet, but you're going to do those on your own. So this one together, what's the first step? Descending order. Is this descending order? Is this descending order? Look at it.
Sure.
We go from y squared, x squared, to x to the power of what?
Y to the power of 2.
X to the power of 0.
Oh.
There's no x in this term. When you go descending order, you have to go with the variable, remember? So we got to flip some of these things around. So it won't always come out in descending order. Sometimes you're going to have to change it. What would descending order actually look like? Matthew?
It can be negative 2x, y, and then
And then negative 6x. And plus AP y squared. You're right. Yes, I'm.
Because it increases the x squared and then you have 6 x x I would say exponent.
Yeah.
Doesn't matter which one goes first.
Nope. You could flip it. You could flip this and make this just here. 15x squared, 15xy squared is on the other side, and you still get the same answer. Sorry, that's. You might get a different answer, but it would work out to be the exact same if you both put it back in. 99% of the time, it'll be the same answer.
So is it like an alphabetical order?
Yeah. So the reason it's alphabetical order is because x, the highest one, is to the power 2, and y, the highest one, is to the power 2. So then they went alphabetical after that. Okay. Next step. Draw your line. What's the greatest common factor on the left side? Johnny, greatest common factor on the left side? 5 what? You got it. And what are you left with? Matthew.
X and negative 3 y squared.
Yeah, y squared. So, what I did was we took this side right here, and I highlighted in blue for it. And I looked at the coefficients. I looked at 5 and 15. I wanted to find the largest number that divided into 5 and 15. That's 5. So I put it here. And then I looked at the variables. I had x squared and I had x. And I took the lowest one. So x has an exponent of 1, x squared has an exponent of 2. I took the lower one, x, right there. And then I couldn't take any y's out because there was no y's in the first one. And then I wrote out what I was left over with. 5x squared divided by 5x left me with just 1x. 15xy squared divided by 5x left me with a 3. 15 divided by 5 is 3. X divided by x is 1. And y squared divided by nothing. There is no other y to divide out. It's left 2. Next one. Negative 6 is what we're going to take out. It left you with x. And it left you with negative 3 y squared. Those two things are the same. What's the greatest common factor we're going to take out, time? The greatest common factor we're going to take out is x minus 3y squared and x minus 3y squared. And then we're going to multiply it by what we have left over. 5x.
So whatever you got going to outside of the brackets goes in those.
Yeah, it goes is your remainder. So what's left over. Goes to the next set of brackets. Any questions about these examples? You guys have a lot of time, the rest of class, to finish the notes. You guys have a note package that still has 2 more slides on it. And then you guys can work on your practice booklets. Those of you who owe me assignments can hand them in.